Dah.
Assalamualaikum warahmatullahi wabarakatuh. Today our group will be presenting university database. Before we start, let us introduce ourselves. My name is SITI SUHAILA binti MOIN and my team members are SITI SURAYA binti SABRI. Next.
Now we start with introductions. The Student College Registration System modernized the traditional manual application process by offering a faster, more accessible online platform for students to submit applications, upload documents and communicate with the institution. It enhanced administrative efficiency by automating key tasks such as application review, program selection, document verification and room allocation, reducing delay and minimizing errors. With secure data storage, storing strong authentication and role-based access control, the system ensures that sensitive information remains protected. Overall, it improves accuracy, speed and transparency, creating a more efficient and reliable registration experience for both students and administration. Next. The first objective is to enhance and ease the student enrollment procedure by enabling applicants to enter their information online without requiring physical forms. Second, to effectively store and manage student data in a central database for convenient access, updates, and validation. Third, to give students immediate updates about their application progress, necessary document, and subsequent steps. And the last one is to safely store confidential student information with appropriate access management and authentication to safeguard privacy. Next.
We have 5 main entities. The student table captures essential personal details. The room table is the core of our inventory using room ID as the primary key. A key feature here is the current occupancy field which allows the system to track how many students are currently in a room versus its maximum capacity. When a student applies for a room, the data is stored in the application table. To ensure consistency, we use a default constraint to set every new application status to pending automatically. Once processed, the application is linked to the room assignment table, which bridges the gap between a student request and their physical room. The relationship between student and application is one-to-many, allowing student to have a history of application. Between application and room assignment, it is one-to-one, ensuring one specific request leads to one specific placement. Finally, room-to-room assignment is one-to-many, as one room can be assigned to several different students. The admin table stand alone. It is designed for oversight, allowing administrator to track who approved application or assign room without being tethered by foreign keys. We also utilize enum, types and foreign keys to prevent invalid data entry and maintain high data integrity throughout the system. Next is data dictionary. Every student is uniquely identified by a student ID, which is our primary key set to auto-increment. This means the system handles ID generation automatically every time a new student registers. We have also applied a unique constraint to the student IC field to maintain data integrity and prevent double registration. As you can see, we use specific varchar links for different attributes. For instance, 100 character for names and emails and 12 character for the IC number. For the profile image attribute, we use a varchar 255 to store the directory path of the upload image file. This structure ensures that our system is not only organized but also optimized for high-speed data processing. This is where we manage our campus inventory. Each room is identified by a unique room ID. We track the physical location through the block name and room number. A critical feature of this system is how we manage housing capacity. The capacity column defines the maximum limit, while the current occupancy column, which starts at a default of 0, allows the administrator to see exactly how many students are currently assigned to that room at any given moment. The table uses application ID as the primary key with auto-increment enabled. To ensure each request is tied to a valid student, we have a foreign key named student ID that refers our main student table. For the application workflow, we utilize an enum data type for the status column, restricting entries to pending, accept or reject. By setting the default value to pending, the system ensures that every new submission is captured correctly without manual status entry. Finally, we track the timeline of each request through two specific date fields. Apply date to record when the students submit their form, and decision date to log exactly when an administrator made a final decision on the application. The table uses admin ID as the primary key, which is set to auto-increment to ensure every staff member has a distinct identity. We store the administrator full name and email address using the varchar 100 data type. For security, the password field is allocated 255 characters. This is deliberate choice to allow for secure password hashing, ensuring that sensitive login information is protected according to modern security standard. It is important to note that this table remains standalone. It doesn't need to be linked to other operational tables like group assignments, as its primary purpose is to provide access control and oversight for the administrators who track system activities and approve application. This is essentially where the magic happens, as it officially pairs an approved application with a specific room. Each assignment is tracked by an assignment ID, our primary key, which use auto-increment for seamless record creation. What makes this table vital are two foreign keys, application ID and room ID. These keys act as anchors, ensuring that we can assign a room without a valid application, nor can we create an assignment without a valid room in our inventory. We also include an assign date field to keep a historical log of when each placement occurred. This structure not only prevents data entry errors but also allow administrators to generate report on how quickly rooms are being filled and manage the student housing flow efficiently. Next.
The system uses several key tables to manage student registration and room placement. The student table stores personal and contact details, while the room table keeps information about room blocks, capacity and occupancy. The application table tracks each student college application and its status. The admin table stores administrator login details. Finally, the room assignment table links approved application to assigned rooms. Together, this table supports smooth and organized management of the college system. Next. So, for list of attributes, the table shows the students, room application table, admin and room assignment table. Next.
Let's focus on list of PK and FK. Our college registration system is built on a robust database structure featuring 5 key tables: student, room, application, admin, and room assignment. Each table utilizes a primary key with auto-increment for unique identification, while foreign keys in the application and room assignment table ensure seamless data integrity between student requests and room inventory. We have implemented smart logic such as unique constraint for IC numbers, enum types for automated pending status, and default values for occupancy tracking to ensure the registration process is both efficiency and secure. This standalone admin module oversees the entire life cycle from the initial student profile creation to the final room placement date. Next, list of relationship. Our system architect is defined by 3 primary relationships that ensure a logical flow of data. First, the relationship between student and application is one to many, as one student can submit multiple application over time. Second, the link between application and room assignment is one-to-one, meaning each specific application result in exactly one room placement. Finally, the connection between room and room assignment is one-to-many, allowing a single room to accommodate multiple students based on its designated capacity. These relationships are enforced through foreign keys, such as student ID and room ID, to maintain total data integrity across the registration process. Next.
The SQL queries presented support the main function of the student registration and room assignment system. The first set of query focuses on adding new records, such as inserting student information and creating application entries when students apply for college admission. Updates to applications, including approval decision, are handled through queries that modify status file. The system also manages room assignment by inserting placement data and updating room occupancy once a student is assigned to a room. Additional queries allow administrators to check for available rooms, retrieve all applications submitted by a specific student, and display a list of students along with their assigned rooms. Overall, these queries ensure smooth operation by enabling data insertion, updating, retrieval, and room management within the system. Next. The ACID means characteristic, atomicity, consistency, isolation, and durability. They ensure database transactions are reliable, secure, and error-free. Atomicity guarantees that a transaction is completed fully or not at all, while consistency ensures data remains accurate and follow all rules after every change. Isolation prevents multiple transactions from inserting with one another, and durability makes sure committed data stay permanent even during system failure. Together, these principles protect data from corruption and ensure organizations can depend on their database for accurate and consistent information. Next.
The last one is data security and privacy. The accommodation database system is built on several security pillars to ensure efficient and safe student placement. We prioritize data privacy by restricting sensitive info like ICs and documents to authorize staff only through strict access control and encryption. For user security, we implement strong authentication with session timeouts to block brute force attacks, while practicing minimalist data collection to protect privacy. Finally, technical integrity is maintained using primary and foreign keys, supported by a robust backup system to ensure our data remain accurate, recoverable, and protect against misuse. Next.
As a conclusion, database has improved our system by creating a more organized, efficient, and management environment. The ERD provides clear visualization of how data is stored and connected, making maintenance and inspection easier. Well-structured tables, key, and relationship ensure accurate data flow, while SQL queries support smooth daily operation by applying ACID properties and strong security measures. The system maintains reliable, safe, and consistent data handling. Overall, the update system offers a solid, secure, and high integrity foundation for effective database management. That's all from our group. Thank you.